A buyer is planning to buy a franchise. The table shows the average weekly profits for a number of current franchises. If the buyer buys a franchise, what would be the expected weekly profit? And round that to the nearest cent. First of all, if we're going to do expected value, we first need to make a table. And we want to get the probabilities of each one of those weekly profits. So here's what we have to do. First of all, we have to look back at the original table and notice there are 13 people who earned 13 franchises that earned 100, 11 for 200, and 12 for 300, and so on down the line. So if you total those things up, you get 59. So there are a total of 59 franchises. Some of them made $100 weekly profits, some of them made $200 weekly profits, some $300 weekly profits, some $400 weekly profits, some $500 weekly profits, and some $600 weekly profits. Now to calculate the probabilities, we simply take the number that made each level of profit and divide by the total. So 13 out of 59 made a $100 profit. And then going down the line, 11 out of 59, 12 out of 59, 10 out of 59, 11 out of 59, and 2 out of 59. And notice if you add those up, you'll get 59 out of 59, which is a probability of 1. Now, as you know, to calculate expected value, you simply take the weekly profit times the probability of that profit, multiply, and then add up all your products. So we want to get the weekly profit times the probability of that profit. So of course you're going to have $100 times 13/59, and you'll have $200 times 11/59, and so on down the line. 300 times 12/59, 400 times 10/59, 500 times 11/59, and 600 times 2/59. You do that arithmetic. Remember, when you multiply fractions, you multiply top times top, bottom times bottom, so that 100 is like 100 over 1, and 200 is like over 200 over 1, and so on. So when you multiply those together, you get 1,300 over 59, and you get 200 times 11, that'd be 2,200 over 59, and then 300 times 12 is 3,600 over 59, and then 400 times 10 is 4,000 over 59, and then 500 times 11 is 5,500 over 59, and finally 2 times 600 is 1,200 over 59. And remember, the expected value is just the sum of all these products. So the expected weekly profit is nothing more than the sum of all those numbers. And I think I'll just write it here. The expected weekly profit, if you add up all those fractions, they all have a common denominator of 59. You get 1300 plus 2200 plus 3600 plus 4000 plus 5500 plus 1200. You end up with 17,859ths. And if we want to write that to the nearest dollar and cent, just take the calculator and you'll come out with $301.69. So that is the expected profit. So you take your weekly profit, compute the probability of each weekly profit, take the product of the weekly profit with the probability, and then sum those up. And then round it to the nearest cent. You could have changed all these fractions to decimals earlier, but the arithmetic is really easier if you don't. But in the end, that's up to you. 80 people who attended at least some college were asked the number of years of college they attended. What is the expected number of years of college attended, and round the answer to the nearest 100th. They've given us the number of years and the frequency, but we need to find out the probability, not just the frequency. So the first thing that we want to do is to create a table where we extend it. We already know that for 1, 2, 3, 4, and 5, the frequencies are 7, 18, 15, 22, and 18. And just as in the previous problem, in order to get the probabilities, we have to sum up all of those frequencies, and it turns out there are 80 of them. And the probability is just the frequency over the total. So the probability that the number of years is 1 is 7 80ths. The probability it's 2 is 18 80ths. The probability it's 3 is 15 80ths. 4 is 22 80ths. 22 80ths. And the probability it's 5 is 18 80ths. And all those fractions add up to probability of 1. Then you want to take a product. You want to take the number of years times the probability associated with that number of years. So you end up with 1 times 7 over 80, and you end up with 2 times 18 over 80, and 3 times 15 over 80, and 4 times 22 over 80, and 5 times 18 over 80. And when you calculate those products, as before, when you multiply fractions, and 1 is like 1 over 1, and 2 is like 2 over 1, and so on. So you do top times top, bottom times bottom. So you get 1 times 7 is 7 over 80. And then you do 2 times 18 is 36 over 80. And then you do 3 times 15, and that's 45 over 80. And then you do 4 times 22, which is 88 over 80. And then finally 5 times 18 is 90 over 80. And if you add all those up, you'll get the expected value. So again, the expected value is the sum of all those products. So again, the expected number of years is equal to, well, when you add those up, you get 7 80ths plus 36 80ths plus 45 80ths plus 88 80ths plus 90 80ths. When you add like fractions with like denominators, you just add up the numerators. And 7 plus 36 plus 45 plus 88 plus 90 is 266. So you get 266 80ths. And if you want that answer as a decimal, a dollar to the nearest, in dollars, well, actually this is in years, years to the nearest hundredth, that would be 3.33 years. not dollars, but years. The units are are years here. There were dollars in the last problem. The units are years. So the expected value is 3.3 years. An investor has $11,000 to invest in the stock market with the probabilities of the outcome given in the table. What is the expected gain to the nearest whole number? Well, as with all of these expected value problems, you need to have a column for the probabilities, and we usually write the probabilities second. There's no absolute reason that you have to, but we're sort of used to seeing the probabilities written second, so I'm going to flip these around just for familiarity purposes. And remember, no gain is the same as 0%. And that probability is 0.08, and then a 21% loss, 0.51. And remember, a 25% gain would be 25%, which is positive, but a 21% loss would be negative 21%. So just be careful how you write those things. And then, of course, to get the expected value, you're going to take the change and multiply it by the probability, as always. So you'll get 25% times 0.41. You'll get 0% times 0.08, and you get negative 21% times 51. Now when you multiply these out, 25 times 0.41 would be 10.25%. 0 times anything, of course, is 0, so that'd be 0%. And negative 21 times 0.51 will be negative 10.71%. And as usual, to get the expected value, you just sum up those products. And so your expected change is 10.25% plus 0% minus 10.71%. If you do that arithmetic, you end up with negative 0.46%. Since it's negative, that represents a loss. So if the investor put in $11,000 and there was expected gain, which was negative, which is essentially a loss, then the investor would have an $11,000 investment times a negative 0.46%, which of course if you change that to a decimal so you can do the arithmetic would be 11,000 times negative 0. When you drop the percentage, you move the decimal 2 places to the left, so it'd be 0.0046. And if you multiply that out and round it off to the nearest cent, it comes out to be negative 50.60. But it actually said to round it to the nearest whole number, not the nearest cent. So to the nearest whole number, that would be $51. Let me just write it over here. They ask you to do it to the nearest whole number, not to the nearest cent. So if the investor invested $11,000 under these conditions, that investor should expect to lose, and again I need to put that negative in there, lose $51. Again, just to make it easier to see. The investor should expect a $51 loss, rounded to the nearest cent. So it's negative $51, which again is a loss. The negative indicates that it's a loss.